Hmm. Do you know that any actions of pushing or pulling on an object are considered as force? Yes, it is. Want to learn more about forces? Let's learn with me, Cikgu Hasnita. Assalamualaikum and salam sejahtera. Hello everyone. Welcome back to my channel. To all teachers, students, and my subscribers, thank you very much for your support. And to our new viewers, this is Physics DLP classes Form 4 with me, Cikgu Hasnita from SMK Baganjaya. So now we have reached Content Standard 2.6, Force. And as usual, these are the learning standard which you have to fulfill. Number 1, to define force as the rate of change of momentum. Second, to solve any problems involving F equal to ma. So are you good to go? Let's check our lesson with the first slide. So students, what do you understand by the word force? What does it mean? As I mentioned in the first part of this video, any actions of pushing or pulling of an object can be considered as force. So in physics, how do we find force as? We define force as, yes, a rate of change of momentum. And force is a derived and a vector quantity. Remember derived quantity? Very good. It is a combination of base quantity through multiplication or divisions. How about vector? Very good. Vector is a quantity which has both magnitude and directions. Yes. And this is the general equation for force, where F equal ma. F is the force, m is the mass of an object, and a is the acceleration of an object. Okay, now how about this? Can you name the types of forces involved in all these diagrams? The first one is called as, yes, it is friction, frictional force. How about the second? Very good. This is gravity, gravitational force involved there. How about the third diagram? Yes, that shows magnetic force. And how about the fourth one? Can you guess? A man is pushing a trolley with loaded. So he applied a force to the object. So the force are called as applied force. Yes. Then the fifth one is very easy. Buoyant force acting on the hot air balloon, which lift it upwards. How about the sixth diagram? Again, very good. The force involved there is called as tension. Okay, tension is a force involved with a force applied on a string, for example. And then the seventh diagram. Yes, that is called as drag force. And the last one is spring force. So these are a few examples of forces. Can you guess what might happen to an object when there is a force applied to them? So here we will see the effects of forces which acting on an object in two situations. Number one, if the forces are unbalanced. So the effect might be, number one, it can move or stop an object. Number two, an unbalanced force can accelerate an object, means either to increase or to decrease the velocity. And third, an unbalanced forces able to change the directions of motion of the object. And last but not least, it can also change the shape of an object. So now how about the second situation when the forces acting are balanced? It might cause two possibilities, where the object might, yes, remain at rest or moving with uniform velocity. All right, students. So now let us check for this experiment 1, how to find the relationship between acceleration and force when the mass of the object is constant. So from the equations of F equal to ma, we rearrange where A equal to F divided by M. So what can you say about the relationship between A and F according to this equation? Yes, we can say that the higher the force, the bigger the acceleration, which means when the force increases, the acceleration increases. So this will be our hypothesis. So the setup for this study can be seen in this diagram where you can see there is a trolley attached to a ticker timer and a ticker tape connected to an AC power supply. And the trolley is put on top of an inclined plane. And here you can see this is a load which represents the force applied to the trolley. And this runway is a compensated runway. Compensated runway means a frictionless runway. It's a smooth runway. So what do you think about the manipulated variable in this experiment? Can you name all variables? Yes, they are. For manipulated, it is force. Very good. How about the responding variable? It should be, yes, the acceleration. And how about the constant variable? According to the aim, our constant variable is, yes, the mass of the trolley. And these are the apparatus required in this experiment where you need a friction compensated runway, a ticker timer, AC power supply, wooden block, a trolley, smooth pulley, and also an elastic spring. So what will be the come out of this experiment? Let's check on the next slide. So before we check out on the come out of this experiment, let us go through the method or procedure on this experiment. Number one, a trolley of mass 1 kg is placed on the runway and a length of ticker tape is attached to the trolley. Number two, the ticker timer is switched on and the trolley is pulled by a weight of F 10 Newton. So we begin the experiment by applying a force of 10 Newton to the trolley. And number three, from the ticker tape obtained, the acceleration of the trolley is calculated by using the formula of A equal V minus U divided by T. So students, I hope you still remember clearly how to determine acceleration from a ticker timer, which we learned in the first part of this chapter. Okay, and number four, the experiment is repeated by adding slotted weights to pull the trolley so that F is 15, 20, 25, and 30 Newton. Okay, and these are the table of result where you can see as the forces increases from 10, 15, 20, 25, and 30. So what will happen to the acceleration when the forces increases? So remember our hypothesis, we write that when forces increases, acceleration increases. So when you plot a graph of A against F, it will be a straight line graph started from the origin. So this will give a relationship of, yes, force is directly proportional to the acceleration. So that we have proved the hypothesis. And now in this second experiment, let us find the relationship between acceleration and mass if the force is constant. So here we have the same setup of experiments as in experiment 1. So from this equation, students, where we write A equal F divided by M, what can you say about the relationship between A and M? Yes, we can say that the higher the mass, the lower the acceleration. So this is our hypothesis, where it means when the mass increases, the acceleration decreases, or vice versa. Again, can you name all the variables in this experiment? So for now, our MV is, yes, it is the mass of trolley. So we adjust the mass of trolley by using a trolley of different masses of 1 kg, 2 kg, and so on. And how about the responding variable? Again, it will be the acceleration. And the constant variable now is the force. Okay. And this is the apparatus we required in this experiment. Again, you need a friction compensated runway, a smooth or frictionless runway, a ticker timer, any AC power supply, wooden block, trolley, smooth pulley, and also an inelastic spring. So what will be the come out for this experiment? Again, let's check on them. For the procedure of the experiment, it is similar to the first experiment except the fourth step, where in the fourth step, we repeat the experiment by adding the trolley so that the mass of the trolley is M, 2 kg, 3 kg, 4, and 5 kg. Okay, so these are the table of results from this study where you can see the mass increases from 1 until 5 kg. So what will happen to the acceleration? Can you guess? So remember from the hypothesis, we write that as the mass increases, the acceleration decreases. So students, when you plot a graph of acceleration against mass, it will be an inversely proportional graph where it will give a relationship of acceleration and mass. So we write mass is inversely proportional to the acceleration. And again, we have proved the hypothesis. Okay, students, so from the two experiments we have conducted, we can conclude them as number 1, an acceleration of an object is directly proportional to the force applied to it. Second, acceleration of an object is inversely proportional to its mass, where the relationship between F, M, and A is given by this equation, where A can be written in terms of V minus U divided T. So this mv minus mu is change of momentum, where when we deal with the time, it will give you rate of change of momentum. And this will lead us to Newton's second law of motion. So what does Newton's second law of motion state? It states that the rate of change of momentum is directly proportional to the force and act in the direction of the force applied, where F equal to ma, written in kilogram meter per second squared, or also in Newton. So I guess this is the time you are mostly awaits for. Exercises. Okay, let's check on these questions. In diagram A, it shows a force of F act on an object with a mass M. So what happened to the object? What do you say? Very good. The object accelerates. How about the next question? What happened if the force acting on the same mass is doubled as shown in diagram B? So in diagram B, you can see there are two men pushing on the same box with a mass M. So what happened to the acceleration now? Yes, it is increases. Okay, so what can we say about the relationship between force and acceleration according to this situation? Yes, very good. We say that acceleration is directly proportional to the force applied. Now let's write the next one. What happened if the same force F acts on a mass of 2m as shown in diagram C? So now we keep the force constant, but we double the mass of the block. So what happened to the acceleration now? Very good. It will decreases. Acceleration decreases. So this will give a relationship of, yes, very good. A and M is inversely proportional. The acceleration is inversely proportional to the mass. Okay, now let's check on the second exercises. Here you have to do some calculation by applying this equation of F equal ma. Okay, you are given 4 diagrams here, A, B, C, and D, where each diagram show a box of different masses. And there is a force or forces applied on them. Okay, let's check on the first diagram. There is a single force of 8 Newton applied to this box of 2 kg. So what will be the acceleration of the box? Very simple. It will be, yes, 4 meter per second squared. A is F divided M. Second, There are two forces of 6 Newton and 14 Newton each acting on this 5 kilogram block. So what will be the acceleration of the block? Yes, very good. It is 4 meters per second. So if you notice, even though the forces are marked on the left and right, but they are acting in the same direction. So that's why we add them to get the net force acting on the box. So it is 20 Newton divided by the mass 5. So it will give acceleration of 4 meters per second squared. So I hope you're clear with that. How about C? Again, in C, there are two forces acting on the box of 10 kg, 2 Newton to the left and 18 Newton to the right. So what will be the acceleration? Yes, it is 1.6 meter per second squared. Now we minus or we subtract the two forces since they are acting in the opposite direction. And how about D? How many forces acting on this 12 kilogram block? Yeah, they are 3 forces. Very good. 5 Newton to the left. Again, there is friction force of 5 Newton and 10 Newton on the right. So this would give an acceleration of 0 meter per second squared. Okay, easy, right? Okay, students, so let us now deal with a more challenging question. Question 3. You are given with an object of mass 2 kg is pulled on the floor by a force of 5 Newton and having a constant velocity. The first question is, what is the frictional force between the object and the floor? Second, find the acceleration of the object if it is now pulled with a new force of 17 Newton. So any idea how to find the frictional force? First, when you see this, the object is moving with constant velocity. What does it mean? The net force acting is 0. Why? Yes, very good. The forces acting on the object are now balanced, which means the frictional force is equal to the applied force, which is 5 Newton. All right. And then for B, how to find the acceleration? We can use, yes, F equal to MA, where the net force acting is 17 minus 5. This is the new force applied, 17 Newton, where 5 is the frictional force. Remember, a frictional force always acting in the opposite direction to the force applied. Okay, so the mass is 2 kg. So by this, it accelerates at 6 meters per second squared. In which direction? How to know in which direction? If you look at the example here, let's say the forces of 17 Newton apply to the right and the frictional is 5 Newton to the left. So the net force is 12 Newton to the right, which means the object is accelerating to the right. All right, so now let's check for question number 4. You are given a bus with mass 2,000 kilogram travel with a uniform velocity of 40 meters per second for a distance of 2,500 meters before it comes to a rest. So you have to find the average deceleration of the bus. Deceleration refers to the decreasing in velocity. Yes. And B, the average force applied by the brakes to bring the bus to a standstill. Standstill means it finally come to a stop. Yes. So students, how to solve for A? How to find the deceleration of the bus? So for A, we can solve them using linear motion equation, where these are all the given information, where the distance S 2,500 meter, initial velocity U 40 meter per second, and V 0 meter per second. So how to find the A? So remember linear motion equation, which equation is applicable? So we apply V squared equal U squared plus 2AS. Okay, so the next step we do the substitution where V is 0, U is 40, S is 2,500. So now we can find the acceleration, which is, can you calculate them? So the value is, very good, it is negative 0.32 meter per second squared. Negative sign here shows deceleration, means the velocity decreases. Okay. Then how about B? How to find the average force applied by the brakes in order to stop the bus? So here we apply F equal to MA. Okay, where the mass of the bus is 2,000 kg and acceleration we have calculated in A. So it is negative 640 Newton. Next, let's check on this question 5. This is an SPM 2015 question. So in diagram 5.1, you can see there are two cyclists cycling the bicycle and reach the distance shows in 3 seconds. While in diagram 5.2, it shows only one of the cyclists is cycling and they reach the same distance in 7 seconds. So the first question, you are asked to name the forces acting between the bicycle tire and the road. So what do you think the name of the force acting on the bicycle tire and the road? It is called as, very good, frictional force. Okay. Or also there will be another forces acting, which is the gravitational force, the weight of the bicycle, which is acting downwards. Okay, next in question B, in this question, you have to make an observation and do some comparison on the quantities asked. So number 1, you have to compare the forces applied by the cyclist that cause the bicycle to move forward. So students, remember in 5.1, both are cycling, while in diagram 5.2, only one person cycling. So how we compare the forces acting? Yes, very good. Definitely in 5.1, the forces acting is greater compared to that in 5.2. Or you can also use a mathematical expression where 5.1 greater than 5.2 or vice versa. And then second, compare the time taken to travel the same distance. So in 5.1, it took 3 seconds to reach the destination, while in 5.2, they took 7 seconds. So which one longer, which one shorter? Definitely 5.1 is shorter compared to that in 5.2. And again, you can use the mathematical expression 5.1 less than 5.2 or vice versa. And then number 3, based on your answer in B2, compare the acceleration of the bicycle. So what can you say about the acceleration according to the time they reach the destination? Definitely, in 5.1, the acceleration is greater or higher. And number 4, how to relate the forces applied by the cyclist to the acceleration. So what is the relationship from B1 and B3? You can see that. Very good. The acceleration is directly proportional to the force applied. Okay. And how about C? In question C, you have to name the physics law involved in 5B4. So what is the name of the law which say that the acceleration is directly proportional to the force applied? Yes, very good. It is Newton's second law of motion. Okay, D1. What happened to the acceleration of the bicycle in diagram 5.1 when both cyclists bend their body forward? So what happened when both are bending their body forward? Yes, the acceleration will increase. And why is the reason? Very good. So when both cyclists are bending their body forward, this will reduce the air resistance acting on them. So that's why the acceleration can be increases. Well, students, time flies so fast and it seems that we have come to the end of our discussion. So before I end this session, let us check for a few applications of forces in our daily life. So from the exercises we have conducted before, it's proven that forces allow us to carry out our daily activities. Can you imagine if there is no gravitational force, what happened to all things in the world? Everything will be floating in the air. Can you imagine living a life like that? Very difficult, right? Well, when there is no frictional force, we will sleep while walking, whereas vehicle can become non-stoppable. And without magnetic force, what do you think will happen to this compass? Yes, it will be malfunction. And thanks for the electrical force, whereby electrical forces, we are able to use all the electrical appliances at our home, which comforts our life. So students, today I have shared with you what is the definition for force, where it is defined as rate of change of momentum. And also I have introduced you to Newton's second law of motion, and to solve any problem involving with force by applying this equation of F equal to ma. Well, students, I hope this lesson benefits you and help you to understand force in a better way. And remember not to miss our next lesson on 2.7. It will be impulse and impulsive force. Till then, take a good care of yourself. Assalamualaikum and have a great day. Till we meet again, and bye-bye for now.